here in my garage. Just bought this new Raspberry Pi Pico W here in Missouri. But you know what I like a lot more than materialistic things? The knowledge that I can use this Pi to see when my garage door is open on my phone. All kidding aside, this is a Pico W. It's a tiny little circuit board with a microcontroller. That's this little black chip in the middle. And it also has a Wi-Fi chip under this metal shield that lets you interact with it from anywhere. Microcontrollers like this are everywhere. That smart light bulb you can control from your phone? Microcontroller. The loud toy that plays a song you can't get out of your head? Also a microcontroller. Microcontrollers are like tiny little computers that let you program electronics to do almost anything. When I reviewed this Pico W in June, I mentioned how I wanted to hack my garage doors so I could impress my wife by not leaving them open all the time. After a few months of health issues holding me back, I'm happy to say I finally did it. Now I have no excuse for leaving the garage doors open. And to do it, I didn't even have to write one line of programming. I did it with something called ESP Home. If you've heard of ESP Home, you might be wondering how something built for Espressif devices like this ESP32 runs on the Raspberry Pi Pico. Well, right around the time the Pico W came out, I reached out to Nabu Casa, the company behind the popular Home Assistant software. They were actually working on supporting the original Pi Pico, but it wasn't a priority. With the Pico W and its built-in Wi-Fi, they decided to make it official. ESP Home supports the Pico and Pico W now. But why would you care? Well, like I mentioned earlier, I programmed this Pico W to do exactly what I wanted, but I didn't have to write any code. No Python, no C, nothing. All I had to do was give ESP Home this YAML file, and ESP Home built the software to do exactly what I wanted. When I open the garage door, the sensor on the door tells the Pico W the door is open. Then the Pico W sends a message to Home Assistant. Then, if I leave the garage door open for more than 5 minutes, Home Assistant starts nagging me until I close it. And this setup is all running inside my house with nothing going out to any cloud anywhere. There's no subscriptions, no cloud accounts, no special hardware. But how did I get here? Well, there were two main challenges: getting the ESP Home to work on the Pico and installing the Pico in my garage. Most programming projects start with a hello world. You want to get a very simple program running just to make sure all the basics work. Like if I'm building a website, the first thing I'll do is add a file that spits out hello world to my browser. If I can get at least that working, I'm good. If not, there's no use writing any more code until I get the basics sorted out. In the case of microcontrollers, hello world usually means blinking an LED. There's usually a built-in LED, and the Pico has this nice little one here. So I wrote up some MicroPython code to make sure my board worked, and it did. I got that LED blinking. Then I added a little more code to connect to Wi-Fi, and that all worked great. So I swapped over to the development release of ESP Home and wrote up this little LED blink configuration. This file tells ESP Home everything about what I want to do with the Pico. First, there's a little section to give my Pico a name. I'm calling it the LED Blink Pico. Then you describe the hardware you're configuring. In my case, it's an RP2040 and the specific board is the RPi Pico W, or I guess if you read it fast, the RPi PiCow. I added this little bit since I'm working on the bleeding edge here and not everything in this video is stable yet. By the time you're watching this, it might not be necessary. Then I configure hardware outputs I want to control. In this case, just the LED on the board. And then there's a Wi-Fi configuration section, and for the configuration values, it refers out to a secrets file that stores my Wi-Fi network name and password. Finally, there's a section called interval, where I tell ESP Home to start running some code every half second to turn on the LED, wait, then turn off the LED. So I ran this ESP Home command to compile the Hello World LED blinker and waited, and well, that's strange. The LED blinks, technically, but it's definitely not blinking consistently. I turned on debugging messages and watched from my computer, and I saw that it seemed to be getting stuck in some sort of boot loop. Long story short, I found out that the software library ESP Home uses for the Pico's Wi-Fi seems to have a bug. Right now at least, if you have a newer Wi-Fi 6 network like I do, you might have to force your 2.4 GHz network into legacy mode. How did I figure that out? Well, after trying 2 different Wi-Fi 6 routers, I pulled out a Raspberry Pi 4, set up RaspAP on it, and connected to that, and it worked. So I knew it was something about the Wi-Fi 6 network settings, and it was just a matter of figuring out what setting was causing the problem. That problem took about 2 full days to solve, but hey, sometimes a hello world is hard. Once I figured that out, Wi-Fi worked and the LED blinked like it had never blinked before. That's not a word. Anyway, So next up, I decided to retest everything on another PicoW because in my debugging, I did some weird stuff to that first Pico, and I wanted to make sure that everything I did would work on a brand new Pico. I popped the Pico onto a breadboard with some headers and soldered them on. Then I put a couple sets of screw terminals on the same breadboard so I could use jumpers to connect to the garage door sensors I bought. For the sensors, I bought 2 of these enforcer switches since they seemed pretty rugged. These sensors cost 20 bucks each, but that's not a bad price for a device that has to survive in a harsh garage environment. There are some other options too, but I liked how these mounted to the track. Before I install the sensors, I just need to test them in my office, so that's why I'm using these screw terminals on the breadboard. With ESP Home, these sensors are treated like any other kind of open-close or on-off sensor. You plug one wire into ground and the other into a GPIO pin, then set it up like this. These settings tell ESP Home about how the sensor behaves. The switch closes when it's near the sensor, and that'll tell ESP Home the garage door is closed when the switch is closed, when it's near the sensor. And it's open when the switch is open, when it's away from the sensor. One of the most important parts is this little pull-up true. If you don't set that, then the Pico might show random values sometimes because the pin can be floating, where it doesn't really know if it's open or closed. Usually for a sensor like this, you have to enable an internal pull-up or pull-down resistor. I also set up the LED on the Pico to turn on if the sensor shows the garage door is open, and to turn off if the sensor shows it's closed, using these little if and else statements down here. So yeah, maybe I am doing a little programming, but it's YAML, just kind of crazy YAML. At least it's not as complex as Kubernetes. There are a few other components I added to this file, like the OTA section that'll let me upgrade the Pico over the air, and there's also this API option that's required for it to connect to Home Assistant later. And before you go taking notes, like everything else, all the code I wrote for this video is open source in a GitHub repository linked down below. To flash the Pico, I ran the ESP Home run command. After it was done and the Pico connected to my Wi-Fi, I was able to see the LED going on and off as I moved the sensor. So this setup works, but it's not very useful yet. Right now, the little LED on the Pico lights up when the garage door opens, but that's it. I want to know when the garage door opens from inside the house, and for that, I need to tie it in to Home Assistant. Luckily, as long as you have that API option set in your ESP Home config, the PicoW should be picked up automatically. All I had to do was go into Home Assistant Settings, click on Devices, then click Configure under the garage door Pico. Home Assistant automatically found it for me. After I entered the API password I set up, I could see, straight from Home Assistant, the status of my garage door, or, well, the sensor on my desk. So I added a new card for the sensor in my dashboard, and moving around the sensor, I can confirm it definitely works. And that's great, except of course it's still just sitting on my desk. So it's time to put everything in the garage. The first step was to set up a nicer mounting option than a breadboard stuck on the wall, and at first, I was going to use this 3D printed wall mount, but then I found this little RPi Pico breakout board on Amazon. It comes with screws and spacers and even includes some headers pre-cut for the Pico. The best part though is it has labeled screw terminals for every connection. So I took everything out to my garage and I mounted the enforcer sensor to the garage door track. It was actually a little tricky. You have to put one metal piece in the sensor portion, then kind of squish it onto the track. Then there's a set screw that can be really hard to turn to give it a little extra clamping pressure. And when I say really hard to turn, I mean I gave myself a nice bruise trying to get the screw to back out of one of the 2 sensors I bought. Luckily, the magnet side was a bit easier. It has 2 sets of screw holes depending on how you position it on your door. In my case, there were already holes in the metal brackets here, so I just screwed it into the holes with the self-tapping screws that came with the sensor. The magnet doesn't have to line up perfectly. You can keep it an inch or 2 away. The next step was routing the cable up the wall, and I'm glad it comes with this armored cable attachment. You never know what the kids will stack against things on the wall. It also makes routing the cable along the wall easier, since I can just use these plastic screw-in cable clamps. Then I screwed the breakout board to the wall. Luckily, this is pretty close to where I used to have my irrigation system controller plugged in, so I can get power from there. I screwed the 2 wires coming from the sensor into ground and GPIO pin 2, then I grabbed my Pico and plugged it into the breakout board. I plugged power in, and of course, it looks like nothing happened because the LED defaults to staying off unless the garage door is open. So now, the moment of truth. It worked! Well, at least the LED on the Pico lit up when the garage door was open and turned off when it was closed. I had to see if Home Assistant was also working, so I pulled out my phone, and sure enough, it updates less than a second after the garage door starts opening. Pretty neat! Since I can update the Pico over the air, I'll be able to update it and add the other sensor when that's ready. I started installing it, but realized I didn't have any spare 2-conductor wire to get over to the Pico, so I'll have to put off doing that until after my next trip to the hardware store. But just showing the garage door status in Home Assistant isn't that helpful. I want Home Assistant to remind me to close the garage door, and that's actually really easy to do. I already have the app on my phone, so I can set up a push notification using an automation. Now, before all you Home Assistant experts start yelling at me about writing up some alert YAML instead, I decided to use an automation because I wanted to do this through the UI. And in that UI, I added an automation that triggers on the garage door opening. After a 5-minute delay, it notifies everyone the garage door is still open, pauses for 10 minutes, and repeats until the garage door is closed. To test it, I had my wife open the garage door while I was down in the office, and it worked. After 5 minutes, I got this notification on my iPhone and also on my Apple Watch. And now, I'll never have an excuse for leaving the garage door open again, at least for more than 5 minutes or so. So that's that. I got it all working, and the hardest part of the whole process was getting that LED blinking at the beginning. But the cool thing is, ESP Home now supports the Raspberry Pi Pico and Pico W. And when I mentioned that on Twitter, a lot of people ask why would I choose a Pico over an ESP32 or ESP8266? Well, for one, having more options is usually better. But on a more practical note, the last time I visited my local Micro Center, they had about 100 Raspberry Pi Pico W and only about 3 ESP32 devices. Having one standard microcontroller versus the 100 or so variants of ESP32 boards means it's also easier to standardize support for it. There are other RP2040 boards, but the majority of projects using Raspberry Pi's chip seem to be built around the Pico board. And that also means there are third-party kits like Pimoroni's Galactic Unicorn, which runs on a Pico W too, that I might be able to integrate with ESP Home out of the box. I'm also building a full wall-mounted dashboard with this 10-inch Pi display, and I'll be integrating it and this Galactic Unicorn into my Home Assistant setup soon, so subscribe and like this video for more. Until next time, I'm Jeff Geerling.